All right, good morning, everyone.
Good morning.
Good morning. Last day after a long night. Hope you all are awake. Thank you all for coming here, being here this early in the morning. My name is Greg Lindhorst. I'm a program manager on the PowerApps team, and today I'll be taking you through some of the finer points about our formula language and how to make the most use of it. So I'm going to start with declarative logic. For those of you who've used PowerApps a bit, this might be a little bit redundant, but I think you might find a few things in there to take away that you may not have known previously. I'm going to imperative logic, buttons, and how the user can cause change to occur, how they can save records into databases, and how they can move around with an app to make their experience what they like. And then some advanced topics, patch, for all, a bunch of other stuff that may not be obvious on the surface that would be helpful to you. First off, the two words I need you to take away from this, above all else, please think Excel. I know it's a simple concept, but I hear time and time again, how do I do this in PowerApps? How do I do that in PowerApps? Just pause and ask yourself, what would I have done in Excel? And often that will be the answer for PowerApps as well. PowerApps is heavily inspired by Excel, and I'll explain why. There are two kinds of logic in the world, probably more, but I'll start with these two. Declarative logic. This is logic like Excel, like in PowerApps, where you describe dependencies between things, where you describe a relationship between things. And you're not saying how it should be evaluated or when it should be evaluated. You're just defining these dependencies, these relationships, and the system will take care of the rest for you on its own terms. So it'll optimize that, make it as best as it can so that the app runs in a good way. The other kind of logic is imperative logic, and this is what we are accustomed to using. Visual Basic, JavaScript, C#, all the traditional programming languages are, for the most part, imperative, where they'll say, on click, go do these things in this order, in this sequence. And they're being very prescriptive about, I want you to do these things, I want you to do them right now, and the author of that app is taking responsibility to make sure that's well optimized for the experience. By putting it in the hands, by using a declarative approach, you're putting it in the hands of the compiler, you're putting it in the hands of the system, the PowerApps tool that we create to do that work for you. So the author doesn't have to think about it. And really, PowerApps is not really designed for professional developers. And it can certainly be used by professional developers, and we see that all day long. But we're trying to hit a lower bar. We're trying to make it possible for people that are power users, Excel users, PowerPoint users, people that would not think of themselves as developers to build their own applications. And for that, we need to give as much aid and help as we can from the tool's perspective. So we focus primarily on declarative logic. If you can do things in a declarative way in PowerApps, you'll be far better off. You'll be much happier. But it's not always the case. There are places where imperative is needed, and I'll go through that as we go through this deck. What I'm talking about is how an app is created out of building blocks. And the building blocks that are most commonly used are the formulas and the controls. You build an app by putting controls down, very much like you do in PowerPoint, and then you bind them together using formulas. So controls have properties. Each control has many properties. They might have a font, they might have a text, they might have the size, the color, a bunch of these properties. They're described at the global level. You can get to any one of those objects and their properties from anywhere else in the application. And screens themselves are also controls that have their own set of properties that can be driven from other parts of the app. Formulas bind that stuff together. They're the little pieces of code that connect the dots. There's no large monolithic procedure in this world. You say, this is connected to that, this is connected to that. There's not like a large procedure that's going to do a bunch of work for you. Instead, it's more piecemeal. It's little pieces here and there. The idea is that that's more understandable, that you can go to a piece of logic and you can see how that property is impacted by everything else, and you're seeing the whole picture. So in the case of imperative logic, let's say you had a control with a property. That property might get set from 5 different other places in like a Visual Basic world. And you may not be seeing all the different places that property might get set. You're pushing, that model is a push model where the event is pushing values into the properties. In a declarative world, it's a pull model. And you get to see the formula that describes what goes in that property, and you get to see the whole thing. There's no hidden goo that might be affecting this property value. The formula itself that you see in front of you, that's the only way this property is going to be impacted. There's nowhere else that it can come from. So that helps it understandability and that you can see every way that this property might get influenced by the rest of the application. Now, down here at the bottom, I have some various controls. This is our slider control. This is our rating control, our text input, radio buttons. I'm going to pop out. For each one of these, let's take the slider. There's a set of properties here that I can go set with a formula. So these all right now have very simple formulas, like the default is 50, which is why it started in the middle. It's max 100. Those are just simple constants right at the moment, but I can, instead of using those, I can bind them to other things and make them formulas and make them dependent on one another. Now where that gets, where the Excel influence comes in, just think about Excel references. One cell will reference another cell. B2 is dependent on A1. You type something into A1, and B2 is going to show that value. That automatically recalculates. As I type something in A1, B2 is just going to show that value. You don't have to do anything. The author of the spreadsheet didn't have to do a thing to make that happen. It just automatically happens. That's the nature of a spreadsheet. The same thing goes for PowerApps. At the bottom right, I have two controls, a text input box and a label control. And there's a binding between them. It's not between cells, but it's between the properties of those two controls. So label 1's text is dependent on text input 1's text. And just like Excel, it automatically recalculates. As I type something in the text input, the label is going to display that value. Automatically, the author doesn't have to do a thing to make that happen. So it's very analogous to Excel. And that's why I keep saying, think Excel if you're faced with a dilemma about what to do and how to make it work. References also work across screens and sheets. So in Excel, if you have a workbook, you have multiple sheets, you can reference one cell to another. And there's a syntax for doing that. The same thing goes for PowerApps. Across screens, you can make references to other objects. The entire app is live the entire time. So it's not like you're calling a screen and it's just now coming into existence. No, it's more like when I say I want to navigate to something, I'm just exposing that screen. I'm just displaying that screen that was already there, that was already running. Which gives you a place, if you want to have some hidden values, if you want to have a place to do some scratch calculations, you can create a screen for that where nobody goes, do those calculations, and use those calculations in other places. So the idea is that that entire thing is live all the time. And that's, again, an aid for the author. They shouldn't have to think about, like it would in Access, for example, where I have to open a form, and that form comes into existence right then. I pass parameters to it. No, in this world, that form is already there. It's already taking values. And we'll do the hard work on the back end to optimize it so that we're not running. We are very careful about when we render, and those screens that are off screen, they're live, but we're not rendering them and taking all that time and performance hit. Instead, we optimize it so that we do what's appropriate for that user. So here's an example. I've got three sliders here, one for red, green, and blue. So if I move the slider, the green will come up, the red will come up, the blue will come up, I'll eventually get the white, etc. If you look at this app, the screen, as I was saying earlier, is a control itself. And it has a fill property. That fill property, I can't get all at once, is set to a function called RGBA that takes the values for red, green, and blue from the three sliders that are on the screen. So it's taking those values, and as I move the sliders, the color that comes out of RGBA that's used to fill the background is just automatically happening. Now that's just one property on one control. If I were to, you notice when I had these guys down here, it was pretty hard to see because the text is too dark. We can fix that. So if I select this text box and I look at its color value, right now it's a dark color of some kind. I can say if slider 1's value is less than 10, then use white. Otherwise, use black. And it didn't work. What did I do wrong? Sorry? Oh, thank you. Oh, simple thing like that. So, thank you. So, yeah, it was a little silly I did. That was pretty silly. So I've got the white showing up now. So there's a conditional formatting thing going on. Again, it's recalculating all the time. It's looking at the value of the text box of the slider and making a determination about what the color should be based on that slider value, and just automatically applying it. All right. One other thing I wanted to mention. You notice that I kind of drift in and out of being in the authoring tool and being in preview mode. There's really no difference between those two. When I'm running right here, when I'm authoring formulas, think about Excel. You don't go from a place where you're authoring the spreadsheet to a place where you're running the spreadsheet. The spreadsheet's just live all the time. You make changes to the formulas, they recalc, and here's the new values. The same goes here. I can go and change formulas and see their impact immediately just here in the design time. Now, it can get challenging, like a button control you put down. I'll show you later, but the label, there's ways to edit the label directly in line, which conflicts with being able to press the button. And so you have to be very careful about where to press the button. But in general, the entire app is running all the time, even in this design time experience. So what does that mean? It means that your apps, if you design them in this manner, your app turns into a whole bunch of property values that are set based on formulas. Very much like an Excel spreadsheet. An Excel spreadsheet has all these dependencies between the different cells, which can be problematic. It can be hard to understand what's going on in the spreadsheet, and there's tools to help make that happen. Here's the same kind of deal. This is one of the listings of the formulas for one of our template apps, and it has lots of little formulas. Some really little ones, like record.result, that goes in the text property, and some bigger ones, like doing a patch with taking some text and reformatting it and making it work. So there's a wide spectrum, and you can see some incredible formulas that people have written, pages and pages. And honestly, we need to do a better job of formatting that and making it easier to comment that, and we've taken that feedback, and we'll get on that right away. But this is what you end up with. And as I was saying earlier, this text property on this all group title, the only way that text property can get modified is through this formula. There is no other way. So if you can go find the formula that's driving the behavior you're seeing, that controls it completely. There's no other place you have to look. It's all self-contained. Oops. There is a difference between input and output properties. I'm going to go over this quickly only because people get confused about it sometimes. This list of properties that I had, these are the input properties. You can only write formulas against input properties. Makes sense, right? Output properties are also available, and those show up in IntelliSense, but don't show up here. And then there's a set of properties that are both. They have an input, and they also output that value. So this text input box down here has a set of properties, but you'll notice there's no text property here. That's because the output of the text input box is the text property, and you can't set it on the way in. The user types, and that becomes the text output. And I can use that as the input for the next control. So if I go over to this control, this label control, and look at what it's wired to the output of the previous control. Oh, wait, here's my property, because that's an output property. Now, the way you set the initial value for the text input isn't to set its text property, but to set its default property, which is why it says text input up here. If I change this, it'll just automatically filter through, and I'll see this new default for this control, and I can type over that. Again, we're very influenced by Excel. This is the list of functions in PowerApps. All the green ones are ones that are almost identical to their counterparts in Excel. And we actually spend time with the Excel team, with the DAX team, which does Power Pivot. They're also an Excel-like language. We're all going after the same thing, going after the power user that may understand Excel. There's a couple zillion people that know how to write Excel. And so the more we can tap into that existing knowledge, the better off we'll all be. And this goes pretty far. So imagine you want to do a reverse string search, something that Excel doesn't do. Like I said, you can go ask, how does Excel do it? You might find an article like this, where it gives you a formula that will actually do it in Excel. And you can literally take this exact same formula and apply it to PowerApps, which is what's going on here. This formula up here is doing exactly the same thing that's described in the article. And as I type strings in here, it finds the last word in that string, whatever it may be, and does that automatically for me. So if you could, again, emphasizing that Excel thing, if you can leverage something that exists in Excel, you're going to be in a good place. Now let me go over some fundamentals. Like Excel, we have numbers, text, booleans. We have date times and dates. They're also like they are in Excel in that they are numbers under the covers if you want to manipulate them at that level. All of them can hold nulls or blanks. We use blank because that's also like Excel, and there's an is blank to check if you have a null value. There are also compound data types. There are records and tables of records. Those are first-class citizens to us. They can be nested arbitrarily. You can have tables inside records, inside tables, inside records. But there are no arrays. If you want an array, that's a table that's a single column that just has the heading value usually. There are a set of functions that take tables as values and produce tables. Filter, search, sort. This is essentially how we create queries. So we'll create a filter function formula that says this is what I'm trying to get. Here are the predicates I want to apply. And the output of that filter will be another table. That table I can filter, sort further, and then feed into a gallery control or a data table or some other control that can consume a table. And then a special class of tables are data sources. This is where we get data into the system. SharePoint lists, SQL Server tables, common data service entities are three of the main ones that we interact with. But there's a whole plethora. We connect to Salesforce, AX, a bunch of other connectors that provide that same tabular data. PowerApps currently has over 100 connectors that connect to all kinds of different systems, from Twitter to Facebook to all over. Not all of them are tabular. There's a handful that are tabular, like the ones I described. When I say tabular, I mean they will return tables of information, and you can apply changes to those tables. Twitter, for example, doesn't do that. You can tweet, you can call an API that will do work on your behalf, but it doesn't provide tables of information that are interactive the way that these other ones do. We provide galleries and form controls and data tables that can directly consume these and can interact with them, like saving changes back. You can also interact with them with formulas. There's a patch, a collect, a remove, an update. These formulas know how to interact with those tables and pull information out and put information into them. Everything is strongly typed in the system. To make it work, there's a background compiler running all the time. It's looking at these data sources and going, what does the schema look like? What are the data types for each of the elements of that schema? It's doing that so that it can figure out the dependency graph and filter and push everything to the right places. But it does require that we know ahead of time what the schema looks like. So if the schema changes, the app needs to be reopened and you need to refresh the data source to catch those changes. Usually it's very, not very painful. If you don't do it and there's some new information, that shouldn't be a problem. If you're taking away information, that could be a problem. But in general, that's what you need to do with your apps, is to refresh them when schema changes out from under them. And then something new we're announcing this week is relational data support. Think of it this way. Relational data. You all know relational data. Imagine a schema like this. You have a sales order entity. It has one-to-many lookups to account, to worker. It also has inbound one-to-many relationships from sales order line, where there's a foreign key that points to this table. Set of tables creates a relational graph, much like you've seen in other systems for a very long time. In fact, this picture came from Access. We're going to make it possible for you to walk that graph very easily. So if you're walking a one-to-many foreign key, you can say sales order.account. Wow, I just hopped over to the account entity. .contact. I just hopped over to another entity, the contact entity. And now I'm going to the full name property. So I can move from one entity to the other very seamlessly, and it automatically knows to filter to the right record for the related entity. So it'll get me the right full name for this sales order. Similarly, on reverse one-to-manys, sales order.salesorderlines, or sales order items, that comes in as a collection of items, as a subtable. So this gives me the filtered list of the sales order items for a sales order automatically. And all I had to do was bring in the sales order entity. I didn't have to do anything more than that. And I could just start writing these expressions. It will make it seem like you can get to a huge space. So if you think about the logical view an author would have, at the top is what we have today for a sales order entity. The bottom is how it's fully expanded. So for the one-to-many, now I have the full record and the full records within those records for the entire graph, all the way down. And likewise, I'm going to glom on all these collections for the inbound one-to-many relationships. Those could be huge. So again, it's declarative. We will take care of understanding what the projection needs to be for what you guys ask us for. If you only write an expression that says, get me account.contact.fullname, that one piece of information is all we'll pull from the back end. The rest of it, we won't. We'll optimize that away. So in a sense, not only are you saying what you want to get to, but you're saying what you don't want to get to. And we will do the optimization to ensure that we only pull what we have to keep performance high and to keep bandwidth limitations in check, because all this stuff needs to be able to run on phones as well as on the web and in Windows. So, I don't remember, is there anything else I should have said there? Oh, yes. This is shipping soon. Not real soon, actually, probably next week. This connector, this experimental CDS connector, will start lighting up in production, and you'll be able to use it. Now, I'll show you, I'll use it in a second here. We plan to do this for other data sources as well. CDS is just the first one that we were able to do it with. We very much want your feedback, if this approach works or doesn't work, or how we should tune it to work for your applications. All right, enough talking. Let's do a demo. All right, I'm going to add my data source. You notice I have two CDS connectors here, the normal one that y'all know and love, and this new one called experimental. I'll pick that one. They go to the same data source in the background, it's just a different route. They are slightly incompatible in that adding this relational stuff made changes. That's why we didn't replace the current CDS connector. And we'll have to do something about transition as we move forward. But I'm going to go down here and pick my sales order entity. And I'm going to add a gallery control based on that. Connect up to the entity I just brought in. It's going to go out and create some cards for me, or a pre-canned card. So these gallery views were done by hand. Somebody said, for a sales order, this would look good. And here they are. You can also, of course, customize this after the fact. But here's my gallery. It's got 2 orders in it. Now, just to get us started, I'm going to I'll make this really big. Okay. So the gallery is going to act as a kind of cursor for us. It's going to keep track of the selection of what I'm working with. So I'm going to say gallery1.selected. And now it's going to, I hit dot, and now it's giving me all the fields that are part of that entity that are available for that record. The one I'm going to play with is account. Now, normally that would just be a foreign key, but we've added this relationship support. So instead, I can say account dot, and now it's going to give me all the fields of account. It just hopped from one entity to the other, from sales order to the account entity. And now I can say organizational name, and if it works. Okay, don't know what's going on. Let's see. Did I mention it's experimental? All right, we'll go with it for now. Not sure what's wrong with there. Let's put the form in, and maybe my mistake will become obvious. So I'm going to put a form down as well. I'm going to cook it up to the sales order entity. This is going to take a little time. This is going to put in a bunch of cards that will reflect the fields that are part of that entity. And we'll wire it up to the selection off the gallery as well. Each of those cards is customizable. They're actually composed of a set of controls within each themselves. They have inputs and outputs at the card level that route into the controls inside. And they're manipulatable. You'll see it come up in a 3-column grid. You can change that to a 2-column grid or a 1-column grid. You can move the cards around. You can pick a different representation for the cards. Instead of having label on top, you can put label to the side. There's lots of different ways to interact with the form control. Now, I'm singing the virtues of the form control. You'll also notice one of the downsides of the form control is it's a little slow. It is something we're definitely working on, but it takes some time, some patience. So let me get rid of that. So now it's reflecting the values that are in the gallery. So it's a little hard to see. Blow this up. If I switch from sales order 3 to sales order 4, the form automatically shows me the fields that make up that other form. Now, another new thing we're adding in short order is that one-to-many stuff also goes to the account. So I can pull in the account as a combo box that will allow me to pick the account that I wanted to use for this sales. By default, it shows the account ID. I'm going to change that to show the organization name. Wow, it is just not behaving. Okay, we'll come back to that. The last thing I'm going to show you is the data table. So this, I could connect to sales order, but I don't want to. I want a filtered list of the sales order line items. So I'm going to not do this, and instead set its items equal to gallery1.selected.sales order lines. And then after that's set, I can come in here and say that I want the product name, the quantity. Oh, look at this. There's my organization name. And I bet the account's working now too. Of course it is. Okay, just need a table. That's all I had to do. That's the magic. I know it doesn't seem like magic. It seems like, wow, shouldn't there be more to it? More Shazam or something? But that line, that formula is all I had to write to filter the sales order lines for this sales order and put them in a table. That's it. So it's more about what you don't have to do as opposed to what you do. If I run this app and I switch between records, it all automatically reflects the changes of my selection, showing one sales order versus another. So this is changing, the account here is changing, and I can update that, and here's my table. Also updating automatically. Yes? Oh, that's good. Sorry? Thank you. I like it. It's like a compiler demo. Yeah, that's nice. It's just,
It seemed like magic. It just started working.
yeah, it does, doesn't it? Yeah, it's experimental. It's very clear. All right. Let me talk about delegation a little bit. Kind of a 4-letter word. PowerApps is a client technology. We do everything client-side. That's not a great idea if you have millions of records. You do not want to pull millions of records down to your client on your phone in the middle of nowhere on 3G in order to filter it down to the item that you need, just the one item you need. The way to solve that is to delegate the filtering, the sorting, that work to the server. To say, Mr. Server, please give me the order ID number, blah, blah, blah. We send that, we get back that one order, and all is well. That's delegation. It's not consistently applied across all our data sources. Sometimes you get a blue dot. I'll show you that in an example in a minute with SharePoint, but all of the data sources are uneven. They're all at different levels of consistency with respect to how much of the OData standard they've all implemented. So this continues to be a sore point with people in that they will build an app, they'll make it work for 300 records, 400 records, they'll get up to 600 records, and all of a sudden, wow, it's not working anymore. It's because they've crossed a threshold. If it's less than, if we can't delegate, we will pull down 500 records and operate on that locally. Which means you can get up and running and you don't have to worry about delegation initially. But at the same time, if you actually want to scale that up and deploy that app, you may have a problem down the road. And we're actually working on features to, instead of doing 500, to say 0. Don't ever do that thing. So that if it doesn't work from day one, I know. And I can do something else appropriate. So I know that my app will scale. And likewise, take that 500 and take it to 1,000. Take it to a bigger number because I know my app will always fit within whatever that size limit is. But this is a continuing area of confusion and frustration, and we're well aware of that, and we're working hard to clean it up. The best source of information is an article on understanding delegation. In here, it'll talk about the different filter functions and the different sorts that are supported in delegation at our level, at the PowerApps level. There's also a link in here to the delegable data sources. These are the ones that you can delegate to, and the list of operations that you can do that delegate. If you go beyond this, you will normally see a blue dot that says there's a warning, be careful, so watch out for those blue dots throughout what you do. Okay. Everything to this point has been imperative free. There's been no buttons. There's been no event handler. There's been nothing like that. It's all been very Excel-like, and that's great. And if you can live there, awesome. But there are fundamental differences between an app and Excel. First off, Excel doesn't have buttons. It does kind of, but they fire into VBA and runs imperative logic. It's just completely outside of the Excel calculation engine. Also, there's no way to set a cell value in Excel. If you think about it, all the cells are driven from these formulas. There's no formula you can write that says, go plop this value in A1, like as if the user had typed it. It's just not possible. But there are cases in apps where you need that to happen. You need to retain some state that's more dynamic, that's being based on formulas that are being written. So this is where we depart from the pure Excel model of being data flow based and declarative. So as I've said a couple times, avoid this where you can, but you won't always be able to avoid it, and that's okay. We actually have religious debates on the team all the time about should this be declarative, whatever this behavior should be, or should we make it imperative? There's a lot of people on the team who are like, no, no imperative, bad, bad, bad. It's okay to use it, but just use it sparingly. Use it where you need it. There are a set of controls, like buttons and the app itself, that fire events, like on start on the app, and the button on click, which in our world is on select. Those will run a set of actions on your behalf. You use them to set variables, values, to change screens, to submit data to a server, call a connector, launch a Microsoft Flow. There's a whole plethora of reasons why you have to do this, where a user has to get involved, where they're entering values, but they don't want that to be saved to the database until they've confirmed it. And they hit that big submit button. That's when you want to go to the database. And that's why you need that gate from data flow into the imperative world. There are variables in our world. There are global variables that we introduced a few months ago. It's the simplest ones to use, honestly. You use the set function, you set x to 1. And then you can use x throughout your app. Enough said. I mean, it's just the simplest way to go. There are some legacy variable thingies out there. Context variables. These are local variables to the screen. And there's a place for that. Sometimes you need that facility. They're harder to use because they use record notation to set them using update context and the navigate call. But in particular with navigate, you can use them to pass values from one screen to another, kind of like a parameter into that other screen, if that's what you want to do. And I'll show an example of that in a minute. And then finally, the granddaddy of app magic and Power Apps is collections. These are also app-wide in their scope. They are tables only, one of their weirdnesses. You cannot put a scalar in it. You can't say collection equals 1. You have to put your app in a table, put it in a record, and then you can put that in a collection, which is why global variables are easier to use. Their primary functions are collect and clear, update and remove. They do have this other great quality in that you can load them and save them and load them from the local device. Stored, encrypted, per user, per device on the local thing. And you can use that for offline purposes. Hamath gave a talk yesterday in which he took a data source and he put it on the local device, disconnected from the network, could interact with that data, even make changes to that data, and then when we got back on the network, you could push those changes back to the app. It's super complicated, especially that write-back scenario with conflict resolution and everything else. We will be eventually working on that to make that much easier, so it's very seamless and part of the platform. We just haven't gotten there yet. But it is possible today to do these kind of scenarios. In particular, read-only scenarios where you're just taking data offline and you're just going to read the information, those are relatively easy to build and take advantage of with this facility. All those variables, we don't have a watch window or a place where you declare variables. Instead, you can see them out here in the backstage. There's a collections tab, which will show you all the collections that are part of your app. And you can drill into them and see what their value is currently. As I said, they're all tables, so that's why they show up as tables. And most of it is empty because I haven't gotten to that part of the demo yet. And then there's variables. There are global variables, is the ones that you use with set, like end time. And then there's ones that are context variables that are on a per screen basis. And they also support tables. They also support all the places they get used. So this is the point where it got defined. And if there weren't any places where it was getting used, it would show up there. When we go to the global, it'll be used. So these are all the places where the global end time gets used throughout this app. And I can click through and see that and take me directly there. So that part of that analysis we do to understand the dependency graph, we can expose that information here in the backstage. This is the set of imperative functions. So all those functions we have in PowerApps, I showed you the Excel ones, very much not imperative. These are the ones that are imperative. The red ones are the ones where it actually will change something. It has a side effect. It will change state in your app or change state in a database. And these are the only functions that do a change, do a work on your behalf, that you can't rerun again if you needed to. I talked about this before, but I'll say it again now. There's this compiler that's going on in the background all the time. It's an incremental compiler that's looking at the types in your system and understanding how it all connects together. And it requires this strong typing. Everything needs to have a type. We need to follow that through the system. There's no values that are like objects where it can change throughout the course of the run of an app. It all needs to be declared up front. Dependency cycles are not allowed. Those will get flagged, and just like they do in Excel, those are no-nos. Because obviously, if we create a loop, we got a problem, because we're going to keep running it forever and ever. So loops are detected and flagged and turned off as soon as they're found. And then part of the strong typing is, take the example, variables. You might ask me, well, how do you declare a variable? If this is a strongly typed system, how do you know the type of the variable? And the answer is that all this analysis is happening. So just the usage pattern, when you use a collect statement to put something into a collection, the act of writing that formula will tell us, okay, well, you want this to be the type of that collection. So all that's driven from the actual usage pattern. You don't have to upfront tell us that you need a collection or you need a variable. If you use a value in a collect statement we haven't seen before, okay, that's a new collection, and we've got its type now. If you use a collection in two different dissimilar ways, we will take the union of the two to create a type that covers both of them. That all happens automatically. So like I was showing you a moment ago, the collections, I didn't declare them, and I haven't even used them yet. But like this guy, I'm about to go show you it's used. It's empty right now, but it already knows the column names because I have a collect statement which defines those. So let's do that. Here's a goofy, simple little app. I'll just look at that. Okay, I've just taken 3 sets of inputs, and I've hit this button to cause them to move into the collection. So this is where there's that gate from the declarative world into the imperative. I can type these values over here in the text boxes. They don't really go anywhere until I hit the button. It's gating their movement into the collection. And that's required, otherwise they'd just fill up the collection. It wouldn't make any sense. You need to have a way of imperatively saying, okay, I'm ready, take these values. If I go back to my collection, there are my 3 values that I put in there. So it's keeping track of that, and it can show me those values directly here. And it's the same scheme I had before. I can clear these out, and the scheme will remain. And people ask me, well, how do you get rid of these collections? Well, just get rid of the collect call. All this is driven from what happens on this button click. This collect up here into my collection, taking the saying that comes from the text box, the priority that's the value of the text box, and the order is just driving it from the count rows. It's the counting number of rows that are currently in the table and just adding 1 to it, essentially. That's where I get the 0, 1, 2. It's wrapping that all in a record, which is why you have the curly braces. The saying is a field, the priority is a field, the order is a field. Even the types of those fields is driven from this formula. So the fact that count rows is going to return a number means that order is going to be a number. And so that is a number field that can do calculations on throughout the system. This defines the collection. And the same is true for global variables. The same is true for context variables. This definition does it. So if you want this just to go away, all you have to do is remove this collect call, and Shazam is gone. It doesn't exist anymore. It was like it was never there. Where am I? Okay. Another place that's very common for imperative logic is navigation. So there's moving between screens. You notice I'm moving between screens in this app. The way that works is that there's an image back here that I got from PowerPoint. All these slides, they initially started in PowerPoint. I certainly was going to edit them in here. I started in PowerPoint. I exported the images to a PNG out of PowerPoint and imported them to here as media. The on-click, or on-select, I should say, for this image says that it should navigate to AFD2 and none. What that means is that AFD2 is the name of a screen, and none is the transition to apply. You could swipe them. You could, there's a couple different transitions. I'm not sure of all of them, but there's a set of them like PowerPoint where you can transition between the screens, very much like transitioning between slides. That's the main bulk of this screen, does that. Over here on this side, I have a special stealth empty image control that just has the word back. So if I click over there, it's going to take me back to the previous screen. We keep a call stack, if you will, or a screen stack, of the screens you visited through navigate calls. And at any time, you can say back, and it'll take you back to the previous one. And so this is how this is wired up. So it's quite simple. If I hit this, if I click or anywhere on here, it'll take me to that next screen. If I hit back here, it'll take me back to the previous screen. It's very common. You do this kind of imperative logic all the time in PowerApps. Something you can do is you can also pass a context variable to the other screen. Or you can, rather, you set a context variable on the other screen as part of that navigate call. So down here, I can put a text string here. You notice this is my favorite text string in the world. Hello world. And then it showed up down here. The way that worked is there's a label control here that just says message. That's the name of a context variable on this screen. And the way it got set is on this button control. It says navigate to the screen, don't do any transition, but pass this record, and that record contains context variables to set on the other screen. So this is a way to pass, the user clicked on this. I want you to go to the screen and show them that, whatever it might be. It's a way to pass context from one place to another. Okay. Now I'm going to show you another demo in a second, but I want to prefix it with what app from data does. I want to show you what app from data does when it actually creates something. Actually, why don't I go ahead and start that, since it takes a little time. I'm going to create for an app from data. Instead of CDS, I'm going to use SharePoint. This is the SharePoint list I'm going to use. Here I'm going to give it a screen, the site URL. Use this list. Okay, it's going to go off and it's going to create me a 3-screen app. The 3-screen app it's going to create will have a browse screen, a detail screen, and an edit screen. And these are the main controls that make up that screen. Data will come into the browse screen like we showed before with the gallery control hooked up to the data source. But it's going to pass through some filters. It's going to pass through a filter function and a sort function, which will allow us to have a search box where we can type in the filter, the items we want to look for, and a sort button which will say whether they go ascending or descending. That selection, like we showed before, the selection on the gallery is kind of a cursor. It's like this is the record to work with. It'll feed that information declaratively to the detail screen and to the edit screen. Those guys will have imperative buttons that can do things like delete the record from the detail screen. Or it will have a submit button on the edit screen so it can save the changes. So you can make changes on the form and those will get funneled back into the table. And then finally, there's a bunch of navigation that goes on between these guys. When you go from the browse screen where you say, I want a new record, you put the form into new mode, and then you say, go over and let's see that screen. And from there, I can enter a new item and save it in the database. We say there's edit form, there's new form. Actually, since this slide was written, there's a new form type called display form. So this model of having 3 screens, we've actually got to the point where you can get down to 2 screens. So you can take the edit form, and you can take those controls, and you can put them into a display mode. So you don't have to have separate display screens and edit screens. You may still want those, because on the display screen, you can optimize it for viewing as opposed to editing. But if you don't want to go to that extra mile, and you want consistency ensured between detail and edit, you can do it on a single screen. All right, let's see what I did over here. So here's my browse screen. It has a gallery like we saw previously. Let's look at this formula it created. As a sort by columns, within it is nested a filter. The filter is doing a starts with. So it's taking new list 2 and saying, for compliance asset IDs that begin with the value of the text box, I want you to show those. And then the sort is based on this sort descending 1. That's a context variable that was created on this screen. That context variable is controlled through this up-down arrow, which basically just takes it and reverses it. If it was going up, it comes down, and vice versa, just by nodding the value of that Boolean. Now, I really don't want it to be searching on compliance asset ID. That seems bogus. Let's change that to title. And let's sort on title as well. And now if all goes well, I can type in first, and it filters the list down to that first item. And it's because I typed a value in that text box. It funneled that through the filter function. The filter function did its thing. You notice the marching ants at the top of the screen? That's when it was doing a query against the server, saying, okay, I've got a predicate for you. Go give me filtered values for this list based on these predicates. And it's sorted A to Z. I can reverse the sort so the first shows up first, if that's what I want to do. It's reversing that context variable. Again, it's filtering through the sort. So there's a bunch of stuff going on. Some of it's declarative, some is imperative. The up-down button is an imperative action because it's changing state in the application. It's changing that context variable. And then that context variable gets used in a declarative manner by the sort by columns function and the filter function. All that comes together to give you the experience that you want. Now, I was talking about blue dots earlier. Let's deliberately make this a blue dot experience. So instead of starts with, that is the one function in SharePoint that we can delegate, which conveniently is the one we picked for app from data. Not surprising. If you use CDS or you use SQL, that won't be the case. Starts with won't even be supported in SQL, for example. In this case, I'm using in. This operator is a contains operation. So it's not just going to look for strings that start with that. It's going to look for that value anywhere in the item. So it switched from starts with function to an in operator. And you'll notice I've got this blue underline. And it's explained to me that part of this function can't be executed externally or remotely. Please do better. Please come up with something else. Use a different data sources if this is important to you. What's going to end up happening, and then there's a blue dot here. That's where the blue dots come from. What's going to happen in this case is that because it can't be delegated, we will pull down the first 500 records, and we'll apply those filters and sorts locally. And for a small number of records, that's fine. But if that SharePoint list has thousands of records, tens of thousands of records, millions of records, that's not going to work. Not only will it be insanely slow, we'll cap you at 500. And so where I was doing the sort backwards, we'll only pull the first 500 records unsorted, then sort them. And so you might, by sorting it the reverse direction, you might see C start at the top. No M's, no Z's, because we didn't pull those records. We didn't get that far into the list. So you got to avoid this. You really want to avoid the blue dots. You got to think carefully about your scenarios and whether it's important to use that data source, and if the delegation is more important, then you have to think about moving to CDS or SQL or some other place that supports this. Now, we are enriching this all the time. This is not static. There shouldn't be any blue dots, honestly. It should all be all delegable. But it's not all under our control. All these connectors have to do that work for us. The SharePoint OData head does not do contains operations. We just can't push it. So we get metadata from them that says, we can't do this, please don't send us this. And so we don't. And we show you guys a blue dot instead. We shouldn't be showing you blue dots. You shouldn't have to think about this, but for the short time, you will. Detail screen has an item property equal to selected, just like we saw previously. If you hit the edit button, it puts the form into edit mode and then navigates to that screen. If you look at the edit form, if you press this button, it does a submit form. This is how it saves values back to the database. This is how the app is wired. So you can do these app from datas all day long and look at how it's done. You can use it as a starting point, and many people do, to get it up and running, to make the connections between things, and then make modifications as necessary for the scenario they have in mind. All right. I just showed you the submit form and the form control. By far, the easiest way to deal with data in PowerApps is the form control. It's not very customizable. It is somewhat customizable. There's lots of stuff you can do with it. But there's lots of cases where you're going to want something that's even more custom than it can provide. For example, many people come to us with the scenario of having multiple forms across different screens, where they want to fill in some information on this screen, fill in some information on this screen, fill some information on this screen. And at the end of the whole thing, it's kind of like a wizard filling in information, you hit a button that submits the whole thing at once. And you can't do that with the form control currently. That scenario we hear enough that we'll go do something to make that better, but it's going to take us time to get there. In the meantime, there is the patch function. This is the granddaddy of all data interactions in PowerApps. And this is how we used to do it before we had the form control. And people found it insanely confusing, which is why we did the form control. The idea is that you take the patch, you take the data source, and you feed us the original record that you want to modify. You don't give us the primary key to it. We don't think that authors should have to think about primary keys. They should have to think at that level. You just hand us the entire record, which you should have from the selected off a gallery or from some other means. You can potentially fill us the primary key, and sometimes that'll work, but we prefer you send us the whole record. We can get the primary key information from that record, and we can use that to do the update. And then you pass us a set of updates. So at the bottom line is how we do what I just described, where it's multiple forms across different screens. You can give us multiple updates. The update is just a record that says this field gets this value, this field gets that value. You can give us a patch call that takes all that, takes the patch, and here's the data source, here's the record I want to change, and then here's all the things I want you to do to it. It'll do that. If there's any errors that come back, they're available through the errors function. So you can interrogate that. One of the things the form control did for you is that it handled errors. Patch won't. Patch will just happily go, well, I returned you, there was a problem. I hope you did something about it, which is part of the problem we had with it. So you have to be careful that when you use patch, check the error value that comes back from it, because it will just silently fail. It's up to you to take control over that and take responsibility for it. For all. We had iteration last year, kind of. The reason this is not called for each is that it's not something where we're going to go record by record and evaluate them in turn. Part of our optimization is that we look for opportunities to do parallelism, to do things asynchronously together. So there's no guarantee about the order in which things are going to happen. In practice, it typically is in order, but you can't depend on that. This, when we were debating how we were going to put this in the product, many people said it should just be map and should return a table of values, and it does. But this concept of being able to do some work across an entire data set is really important. And so we decided to settle on for all. Results in a table, you can do the collect either inside or outside the for all. And let me show you an example of both. Should we do this first? Hold on a moment. Our table control has a bit of a bug in it. It gets confused about let me just do that. So I'm adding stuff to the collection just like before. I've got two buttons over here. I'm going to use them to copy values out of this control that are short. So let me do a couple more short ones. And put that into a different collection. So the first of these is going to clear out the collection previously. One thing about collect is that it always adds. It doesn't replace. There's a clear collect which will replace clear and collect, but in general you have to do a clear yourself somehow. What I'm going to do is this. I'm going to do a for all over everything that's in that first collection. And anything that has a length of saying that's less than 10, it's going to filter to just those values. And that's going to be the table I'm going to operate on. For each item in there, I'm going to collect them into my short strings. And that's going to be a separate table that I'm going to show you in a second. So if I click this button, I guess goodbye is too long. But this really long one didn't make it. So that got filtered out. So it went over each one of them and did a collection. Now, it could have done a patch. It could have done a remove, an update. There's any number of imperative operations you could do from that for all. They're all good. But a different way of approaching this is to look at this formula. Here, it's taking for all over that field saying, and it's creating a new table. It's taking the filter and pulling that one field out. And it's taking the result of that, and it's collecting that into my short strings. The result will be identical. If I press this button and account for it losing its mind about what field to show, I'll see the same result. So So it can be used to create a table by walking over a bunch of records. And in that case, the order of the output will be consistent with the order of the input. Or you can have it do imperative work inside the for all. And when you do that, the order of operations is not necessarily guaranteed because we may parallelize that work. Another feature of PowerApps is it has this concept of single column tables. You can take any column and you can say my table that column, and it'll pull just that column information as a new single column table. It's very handy for pulling all the values of first name or full name or something from a table and just taking those out just by saying them by name. So I'm going to show you this button is going to do a collect of my string lengths. It's going to take the length of each string, pull that out, and put it into a new table. So that notation about my strings.saying, that's going to pull a single column table. You're going to run length across it. Most of the functions can not only take a scalar. You would think length could just take a single string, but no, it can take a column of strings. It'll run across the length of all of them and generate a new table of all those values. So I'll press this button. I go to my links, and now I can see all my links for those strings as just a separate column, a single column table that I can use for other purposes. I'm talking about record scope. Within a record, when you're doing things like for all or you're doing filter, the fields of the record that's being worked on are available inside that formula. So example, when I was doing my for all, I said saying, and that's all I had to say, because it creates a context in which you can see the fields of that record directly in those functions. And you can use that to write formulas of arbitrary complexity to drive what you're trying to accomplish. There is global disambiguation as well. So if saying was a control that I wanted to get to instead of a field name, there's a way to say, go get the global version of this, not the one that's in the record context, and use that instead. A couple other things. The text function is very much like Excel's in that it's used for formatting. So it's used for putting currency symbols and putting number formatting for currencies as appropriate. If I press this button, I didn't press it. Thank you. Here are my strings that have been formatted. So the numbers, have taken those and put dollar signs in front of them and put 0.00 on the end of them and did the appropriate thing. That's all being driven by a text function. So if you look at this formula, it's got text down here. It's saying the order and the currency order, and it's applying this dollar sign, pound, zero, blah, blah. This is very Excel-like. This ENUS might be confusing to you. That is not the locale that will actually be used on the outside. That ENUS is telling us how to interpret the dot. If you think about it, that string that has a dot in it, in languages in which a comma is used for a decimal separator, we need to know which one you meant. And so we put that string in there and allow you to edit it so that you can tell us where we should be. Now, by default, when we actually do the formatting, the formulas use the runtime uses the locale of the user who's running the app. The authoring tool also uses the locale of the author. So we will actually transpose dots and commas appropriately when you're looking at formulas. So if you're looking in a language, if you're looking at a PowerApp Studio in a language that uses comma for a dot, you'll also see semicolons used for separators, semicolon uses separators as opposed to semicolon. The whole thing gets transposed and back again as appropriate. You can launch one app from another. There's a way to pass parameters from one app to another. You can launch just a website, but you can also launch a Power App. If you go to the PowerApps admin portal and you look at the apps, the URL and the app ID that you need to use is listed there. If you launch that in a browser, it'll come up in the browser. If you launch that in one of the native apps, we will actually interpret that URL, realize it's a PowerApps URL, and launch that app in the native player. So you never go to a browser and then back again into the native player. It automatically takes care of that for you. You can access query parameters. You can put normal question mark parameters at the end of the URL, and those get passed in as parameters that you can pull out in the app itself. Image handling. Images are just URLs in our world. Now, there can be some funny URLs in there. You might see a blob colon or an appres. Those are stuff internal to us that we know how to interact with. But there are just HTTP, HTTPS URLs that are also available that you might see. So that's how we handle binary data. We don't pass around binary data as a data type itself. Instead, it's passed around as a URL that points to binary data. So let me give you an example. I don't think this got demoed enough this week. And you'll see why in a second. We are in the brink of adding attachments for SharePoint lists. Yay! So here's the attachments control. It's showing 2 attachments out of a list item. Let me pull this, make it some space for myself. And it actually somewhat works. The blue dot is erroneous, but if I click on an attachment, it actually pulls it down, and actually open a word on it. And up comes my favorite saying. But what I really wanted to show you is that where'd it go? Okay. There's a new column here called attachments off the SharePoint list. And because it's possible to have your own attachments column, we couldn't call it that, so that's why it's got the funny curly brace notation. Apologies for that. It can be multiple, so I'm going to take the first. Again, a declarative function that's going to take the first item off of that table, because the attachments are going to come into us as a table. There's a set of properties on that, like the display name, but the one I'm going to show you is the absolute URI. So this is how it looks to us internally. It just looks like a URL. And you can actually feed URLs into the attachments control, and when it attaches a file, it's going to come to us as a URL. Now, if it's on the local machine, it's going to show up as an appres : and then a GUID effectively. That's so that we can track it into the point where you send it up to the server. We'll send it for you. We'll look at that appres and go, okay, that's one of ours. And we'll send it up to the server, make it available as attachment on SharePoint. The next time it comes down, it'll come down as a SharePoint URL. So for us, these are all references to resources, either locally or on a remote machine. Attachments will be coming soon, real soon, promise. It does need some more work, however. Upload I can't show you right now, and there's that blue dot I just mentioned. So some work's got to be done there. All right. I think we've come to the end of our tour. In summary, please think like Excel. Please, 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 please. Not sure what to do? Ask yourself what Excel would do. And sometimes, often, that will give you a good answer, a good starting point. Use that imperative logic sparingly. Obviously, I used it a bunch. You do have to use it a bunch. I'm not going to say otherwise. But I didn't use it in inappropriate ways. Some people will jump right in here and go, where are my variables? I want to set a variable here, and I want to, on entry to the screen, I want to set this other variable and this other variable. You set all those variables, and then you have to manage the variable values, and it becomes really hard for other people to understand and interact with. Just use it sparingly. Variables have their place, that's why they're there, but don't use it, don't overuse it. If you can go with the declarative model, if you can connect one thing to another and just have that dependency, take advantage of the data flow engine that's built into this. We're not the only system that does this. Angular and other JavaScript libraries have been doing it for a while. It makes the apps easier to work with. Enough said. And avoid those delegation issues. We'll do our best to get rid of the blue dots. Unfortunately, they're still going to be there for some time. We will do our best to get rid of them quickly, but watch for them. If you see one and you know that your app is going to grow or has potential to grow, you're going to have to think about a different way to approach that problem. Use a different predicate, use a different data source to get past that. And please evaluate the session. So thank you very much, and I'll take questions.
Thank you very much. This was not a traditional PowerPoint. Is it going to be available after the?
I will try to make it available. You're right. This was not a traditional PowerPoint. This was obviously I was using a Power App. I'll make both the PowerPoint that it was derived from and the app itself available after the talk.
When did you say the relational data is going to be available?
Relational data will be available probably this week for CDS. We were held up on deploying the connector, but all the work is in Power Apps now. It's just a matter of getting the connector to support it. So as soon as experimental connector shows up for y'all, go at it.
I have
Other questions? Yeah.
one question. What I need a lot is that I have a global menu in my app, and now I have to add that menu in every form. And if I change the menu, I have to go through all the forms.
Right.
Is there a smarter way to do that?
Not really a better way right now. We have talked. Sorry, what? Go ahead,
Blog
Brett.
about it. Okay. But you cannot use like modules, which you can use in every form. Yes?
There's no.
Okay.
I don't know what the blog says necessarily, but there's no facility to share like an object across screens or to derive one screen from another or anything that you would want in this area.
Yeah.
I'm sure there are workarounds to make it better, to make it easier to work with, but in general, there's no great solution to this problem right now. Pratap, do you have more to say? Or?
Yeah.
There is a blog where we have used a collection, and you have to on visible of each page update the page which it's in. So basically, it's a smarter way of creating a menu on all the pages. It still requires a little bit of code, but it is still you don't have to change a lot of things.
Right. So
it's on powerapps.com/blog.
That's great. So what he's describing is you still have to put something special on each screen, but what it runs off of can be shared, and so it's easier to update in one
I
place.
understand. Thank you.
Is there a way to connect Power Apps with Logic apps? Because for now we are using Flow, but there is no way to get the entities and something else straight connecting to it.
Go ahead, Pratap.
Oh.
So the Logic Apps team announced just before Ignite that they have a way to export Logic Apps as a custom connector in Power Apps. It was as recent as last week, so follow the Logic Apps tweet or the blogs. You might find it there.
Thanks, Pratap.
My question was related to version control. I noticed that there is a way of controlling versions on
Yes.
Power and publishing.
Yes.
When you do that, though, can you see the differences between versions so that you can make sure that evaluate the changes that somebody did as you get them published by a second person?
No, I totally understand your question. I don't believe there is. James, are you still here? The question was, that we support multiple versions. Is there any way to understand what's different between two versions, besides opening it up and looking?
Not today, but that's something we've actually discussed internally, tackling and having some kind of more, like a change history that's like visual.
Yeah, because sometimes we want to do code review. Like you want a second person to at least evaluate, well, the changes person A did, given that this is a single developer environment pretty much. I mean, you can't have two people, you know, you want a second developer to oversee it and say, yeah, I agree with the changes being done before we go ahead and publish it.
Yeah, I think it's great feedback. It's definitely something we can do, and I'll take that and we'll figure it out.
Okay, thank you.
Did you have something?
Yeah, the for all function, Is that true that you can only work with collections inside the for all?
I did it, yeah.
Is there ability, or will there be a future enhancement to add ability to build variables and stuff inside of for all?
Oh, so the variable thing, that's the reason variables are you can't do a set inside of a for all is it's not guaranteed the order. If people started doing x equals x plus 1 and depending on the order, we'd run into problems because we don't guarantee the order. So that's why they're specifically exempted, why you can't use those kinds of operations inside of a for all. But if you have scenarios, I'd love to understand the scenarios better. There might be other ways to approach it, or we need to add something else to make that possible.
Sure, yeah.
But collect is different. As like I was saying, collect just adds. It doesn't change. It doesn't, and so it's a little different. That's why we allowed that one, but not other ones.
Okay. I think I ran into this scenario once in one of my apps.
Okay.
So maybe we can chat or.
I'd love to chat more with you about it.
Sounds good.
Be great. Yep.
What would you suggest to push multiple rows to a SharePoint list? So for example, an end user is picking items in a collection.
Yep.
You store that in a collection, you want to push all those rows at once to a SharePoint list. How would you do that?
Is a set of changes you want to apply to the SharePoint list?
Just new entries.
New entries. You can collect those to the SharePoint list as well.
Okay.
And the collect works against data sources as well as it does against collections.
Okay. All right. Thank you.
Mm-hmm. Yep.
So going back to the for all, are there any limits? So let's say I want to hit 4,000 item SharePoint list and use a for all to loop through and do some calculations and bring back a subset. Are there any limits on that?
There are no limits on that, no.
What about the return set? So are we hit with that 500 limit?
Sorry, yeah, you're going to hit that 500 limit. Yes, correct. So you said 400. So if we'll only pull down, it doesn't delegate. We can't have a for all operation that we push to the service. So
okay.
We will pull at most 500 records to operate on a for all, correct.
Okay, so it pulls the records first. So if I've got a 5,000 item list, I'll get the first 500.
Correct.
Okay.
Correct.
Well, thanks.
You're welcome. Other questions?
One question. Is there a way to expand the edit window in creating a formula? Because some of these formulas really get big, other than copy and pasting out of.
I mean, yes, you can.
Notepad.
This is, you can pull this down, just like you do in Excel.
Perfect. Thank you.
Yeah, it's not, and you can expand and collapse it fairly easily.
Okay.
We'd like to do more, because these formulas can get really nasty.
Right.
We'd like to have pretty printing and comments, and we'll get there over time.
Perfect. Thanks.
Mm-hmm. Other questions?
One more question. So in the SharePoint example, you had a filter that was just applicable to one column.
Correct.
How would you handle if you wanted to do it across multiple columns? Is it just nested if, trying to figure out the logic of the if?
Oh, it's just an and. So
Okay.
filter x greater than 3 and y greater than 4 and or you can use ors and nots and Boolean logic inside there.
Okay. So if one value was, or one filter had a value and didn't have a value, it would take into account a value, a filter value
Correct.
that wasn't selected?
So a scenario we've had, I should bring that up in this deck, where people have search boxes where they'll have search for company or state or a bunch of different criteria.
Mm-hmm.
And for the ones where somebody doesn't type in, they just want it to be everything. The best way to handle that is to test and say, is blank on that thing? So to say, the exact format we used. The predicate is blank of country, or country equals what's in the text box.
Okay.
And that way the or would evaluate to it's blank, so that becomes true. And the way we don't have to delegate that because that's a static value for all the records. So we can optimize the expression down to say is blank. Okay, that's true. So this whole thing, that whole clause becomes true.
Okay.
And so the or is true, and so it cascades from there. And so SharePoint isn't even aware of that. It just never gets to them that level.
Okay, and that would work with more than 500 records?
Yes, it would.
Okay.
Because that would delegate very easily.
Perfect. Thank you.
Sure. Other questions? Okay, if anybody has anything else, please come on up. I'm happy to talk. Thank you.